In this video, we're going to first determine whether or not L'Hopital's rule applies, and if it does, use it to calculate limits. So if we look at our first graph, as x goes to infinity, x goes to infinity, and ln of x also goes to infinity. It is, even though it increases slowly, it is an always increasing graph. So this is an infinity over infinity case, which qualifies it for L'Hopital's rule. And that means we're going to recalculate the limit after we take the derivative of the numerator and denominator separately. The derivative of x is just 1. The derivative of ln of x is 1 over x. Now, this can be simplified before we go ahead and take this limit. Limit as x approaches infinity. We're dividing by a fraction, which means we can flip and multiply, so this simplifies to x. And as x goes to infinity, x goes to infinity. So we find out that this limit goes to infinity. It doesn't have a limit. Let's look at a couple more. Limit as x goes to infinity of e to the x plus x over 2e to the x plus x squared. The numerator is going to go to infinity as x goes to infinity, and so will the denominator very quickly because of those exponential pieces. So this is clearly a L'Hopital's rule. And then we'll take the derivatives and we'll recalculate the limits. E to the x, easiest derivative we have is just e to the x. Derivative of x is 1. Here we have derivative of 2e to the x is 2e to the x. Derivative of x squared is plus 2x. Now here, we're going to have the same thing, an infinity over infinity case. So let's not even hesitate. Let's just go ahead and use L'Hopital's rule again and see what happens. Limit as x goes to infinity. Well, the derivative of e to the x is still e to the x, and the derivative of 1 is 0, so it goes away. And here, 2e to the x plus 2. Once again, we've got an infinity over infinity case. So we're actually going to use L'Hopital's rule again and see if we get a more simplified piece to take the limit of. Well, the derivative of e to the x, again, is e to the x. Derivative of 2e to the x is 2e to the x. The 2 goes away because it's a constant by itself. Its derivative is 0. Now, we can actually cancel out those e to the x's, and we just have limit as x goes to infinity of a constant, which is itself, and our limit is 1/2. So that's a nice one in demonstrating how we have to calculate the limit several times. This next one, you won't always see written like this. In fact, a lot of times this will start off as limit as x goes to 0 from the right of x times ln of x. And our first step would be to rewrite it this way because our graph of ln of x, as x goes to 0 from the right, goes to negative infinity. So this is y equals ln of x. And y equals 1 over x, as x goes to 0 from the right, goes to positive infinity. So this is an infinity over infinity case in this written this way, but this way it's not as easy to see. So first step would be to take this and rewrite it in this form. As you can see, flipping and multiplying the 1 over x would give us this. So a standard way of asking this question initially looks like this. So we're already in a form here where we can use L'Hopital's rule and take the derivative of the top and bottom and see what's happening. The derivative of ln of x is 1 over x. The derivative of 1 over x, we normally rewrite that as x to the negative 1. That's negative 1 over x squared. Now before we do anything else, before we go try in the L'Hopital's again, let's simplify. So we can flip and multiply, and we have 1 over x times negative x squared over 1, which will simplify a little bit further. Limit as x goes to 0 from the right. We can cancel out one of those x's, and we get just negative x. Now we can solve via direct substitution, and this limit comes out to be 0. So always simplify before you reapply L'Hopital's rule, because what you have may be easy enough to solve already.